PyTorch is installed. But is it using your graphics card? For more people than you'd think, the answer is no. Torch.CUDA is underscore available returns false, and the model crawls.
In this guide, you'll check your GPU with NVIDIA-SMI. Install the right CUDA built 3 different ways, verify it in 1 line of code, and watch a GPU leave your CPU in the dust. Let's get started.
Why does GPU matter? A graphics card has thousands of cores made for parallel math, exactly what machine learning needs. And this is where Conda shines.
CUDA, the software that talks to your GPU, gets installed inside your environment, so there's no system-wide CUDA toolkit, no path conflicts, and different CUDA versions can live side by side. In 2026, there are 3 ways to get a GPU built: conda-forge, the official PyTorch channel, and UV, the path this series already uses. All 3 work, and this guide shows you when to pick each one.
Here's what you need: an NVIDIA graphics card with its driver installed, the DS environment from the last episode with UV inside it, and a terminal, the Miniforge prompt on Windows or terminal on a Mac. 1 minute to check the GPU, 2 minutes to install, 1 line to verify.
Skip the last episode. The previous video showed the exact command. UV pip install torch, torchlio -- index URL, download.pytorch.org/WHL/CU126. We'll build on that.
First, confirm your GPU is visible. Type NVIDIA-SMI. You'll see a table. Your GPU name, like RTX, the driver version, and the CUDA version your driver supports. Check this table twice.
If NVIDIA-SMI says it's not recognized, the driver isn't installed, and the errors section fixes that. If your GPU appears, you're ready. 1 rule: the driver version decides which CUDA builds you can run. Newer driver, newer CUDA.
Path 1. conda-forge. Create a fresh environment and install the community package conda create -nml Python 3.12 -c conda-forge. Then conda activate ml. Then conda install PyTorch-GPU -c conda-forge.
conda-forge ships the newest PyTorch builds, including support for the latest Blackwell GPUs. One warning: if another channel sits above conda-forge, conda may silently swap in an older build. Make conda-forge first, or set channel priority to strict.
Path 2, the official PyTorch channel. On the PyTorch website, previous versions page, you'll find conda install PyTorch, Turdibafi, Torch Audio, PyTorch-CUDA equals 12.6 -c PyTorch -c NVIDIA. This is the official command, and it works well on Linux. On Windows, caveat.
As of August 2026, the official channel's Windows CUDA build lags behind at version 2.7, so for the newest PyTorch on Windows, conda-forge is the better choice.
Path 3, UV, and this is the one this series recommends. With your DS environment active, run the command from the last episode. UV pip install torch, torgemisio, torchaudio, -- index URL, download.pytorch.org/WHL/CU126.
That index URL is the secret. It pulls the CUDA build, not the CPU one, and in 2026, PyTorch 2.11 made CUDA 13 the new default on PyPy.
If your driver is recent, the CU130 index works too, and CU126 stays the safe choice for older drivers.
Did it work? Run this 1 line. Python -c, import torch, print torch.cuda.is _ available, print torch.cuda.get _ device name 0. You want to see true and your GPU's name RTX something or GeForce something. Also print torch.version.cuda to see the CUDA version bundled with your build. True plus a GPU name means your PyTorch is now GPU accelerated. That's the whole payoff.
Let's see what that means. Run a large matrix multiply, the same operation, on CPU and on GPU.
The CPU version finishes in a few seconds, the GPU version in a blink. For large matrix operations, GPU acceleration is typically 10 to 50 times faster than a CPU.
Training a small neural network shows the same story. Minutes on CPU, seconds on GPU. This is why every machine learning setup guide ends with the same advice. Check CUDA is available before you train anything.
3 tips. 1. If you bought a brand new GPU, a Blackwell card, your old PyTorch build may refuse it, and the fix is a recent build from conda-forge or the current CUDA index.
2. Keep channel priority strict so Conda never swaps your GPU build for a CPU one. 3. Prefer a fresh environment for machine learning. And remember, you never needed a system-wide CUDA toolkit at all. Conda managed the CUDA runtime for you inside your environment.
Real setups, real errors. 1. CUDA is available returns false. You almost certainly installed the CPU build. Reinstall with the index URL or the GPU channel. 2. Conda says superseded by a higher priority channel. Another channel overrode your GPU build, reorder channels, and set channel priority to strict. 3. Packages not found, PyTorch-CUDA equals 12.0. That CUDA version isn't published for your PyTorch. Use the version the website lists. 4. Your GPU is not compatible with the current PyTorch installation. New GPU, old build, install a newer PyTorch. 5. NVIDIA-SMI is not recognized. Install the NVIDIA driver and restart. 6. On PyPy, the new default is CUDA 13, and a 12.x driver may fail. Pin the KEU126 index instead. Every error has a one-line fix.
Here's your 5-step recap. 1. Check your GPU with NVIDIA-SMI. 2. Pick a path, conda-forge, official channel, or UV. 3. Install the CUDA build with the right index or channel. 4. Verify with torch.cuda.is_available. 5. Enjoy the speed.
Conda managed your CUDA, UV installed your PyTorch, and your graphics card is finally working. If this helped, hit like, subscribe, and comment. And stay tuned. Next episode, we build and train your first machine learning model with this GPU accelerated PyTorch. See you there.